Okay, what are we on? Video 13, something like that. We just finished up boost control, and now we're going to move over into ignition. Now, realistically speaking, I can't even begin to touch on everything that surrounds a proper ignition table, an efficient ignition table that approaches MBT right, and makes the right torque everywhere, and with timing increase versus RPM, staying ahead of the flame front, and how that ties into knock control and pre-ignition versus knock, and how they're totally separate. It goes on and on and on and on and on, and there's mountains of information out there when surrounding ignition timing, and how to go into monitoring knock, and how to find MBT, maximum brake torque. It's also called other things, but that's a pretty common term. I'm not even going to try and get into it. What I'm going to do is give you the bare bones essentials to know that you're on the right path. So that's pretty much all I'm gonna say. You're on the right path to understanding how an ignition table should sort of look. And again, before I even start messing with this graph, I've messed with it a little bit just to clean it up. But given the particular platform, you can decrease timing around peak torque, and it'll be a vast difference from one engine to the next as far as how much you have to pull it back, how much you have to retard the ignition timing around peak torque, and how much to advance it after peak torque all the way to redline. And then same thing goes. I mean, your head design, whether it's a pent roof or all that kind of stuff. The combustion chamber itself can change how your ignition map looks. So what I'm going to do is I'm going to make a very, very generic, simple timing map to give you some like the basic of the basic concepts here, and then you guys can modify as you see fit, because I do not feel like making 30 videos on this, and it would take at least that. So anyway, I've modified this base ignition map a little bit, just to kind of clean it up. And what I'm going to show you here is just some really basic trims, or I'm sorry, not trims, trends. Where you're going to notice over here, this is reflective of kind of what we did with idle. And make sure, like, these are basically your idle values right here. And just make sure that as it climbs out of your idle saddle, right down in here, this little idle floor, that you don't get crazy values, like I was showing in your other video. Make sure that your ignition map doesn't look something like this, okay? That you don't have these weird values in the middle of nowhere. You want a very smooth, gradual timing graph, okay? And I'll just go ahead and smooth those back out there, okay? Now, like I was saying in the idle video, these can be, that's a decent number to start with for idle. Once you get up here, this is basically your main cruising section in here, okay? It's pretty common to see values of about anywhere from 35 to 40 degrees before top dead, all up in here for fuel economy, throttle response, things like that. It's pretty common, and I'm just going to leave it at that, because if I go any further, I'm not actually giving correct information, because it's totally dependent on each car. The actual best quote I ever saw anywhere on a forum was the correct amount of timing is just the right amount of timing, and that's basically the best way to put it. Anyway, so we've got roughly 40 degrees up here, in cruising, and what you'll notice as you start to come into boost, the numbers drop down, anywhere from 1 degree to 2 degrees to several degrees per several pounds. Just notice that the trend as boost starts to come in, it starts to go down. Okay, you start to pull back on the timing advance. Okay, and then you'll notice that if you go from left to right here, if you increase RPM, the timing will actually start increasing, so it'll start advancing again. Okay, and the purpose for this, I'll start here where it's the increase with engine speed. The purpose for this is to basically keep the spark and the whole combustion event and everything, to keep the combustion event very smooth and to keep the spark ahead of the flame front. Okay, now again, this is diving into a lot deeper stuff, but just notice that the spark increases slightly, and depending on what fuel you're using in your particular setup, this may be hardly an increase at all. It may be much more aggressive. This might be a value of 23 over here, and it increases almost 1 degree for every 500 RPM. It's just totally dependent on your setup. But just notice, I'm just going to point out these very basic trends. Notice the decrease in timing as boost increases, and notice the timing increase as RPM increases. Okay, very, very, very generic trends. Okay, to just know that you're on the right path. If your timing graph is smooth and is somewhat relative to these values that I've got here, you're on the right track to being ballpark. Okay, and that's basically all I'm going to say about that. So that's pretty much it. That's all I'm going to touch on with that. Everything else is totally dependent. Take it to the dyno. Look at power output versus how much timing it has. Watch your torque curves. Build your timing around your peak torque. Keep in mind that all that is relevant to what fuel you're using, the octane that you're at. It's totally dependent. So I'm just going to stop with ignition right there. And then I'm going to run over here to, let's see here. We'll go down to the knock tab. Okay, now I'm going to skimp over this pretty quick too. Basically what this is, the knock sensor calibration, for a given engine speed, okay, this is a predetermined knock line. Think of this as a threshold. Okay, so what you're telling the ECU is basically, if I'm at 4,000 RPMs and I'm underneath 1.1 volts, then all of this is regarded as non-knock. So even though I'm seeing some voltage here, and it's going to grow naturally with engine speed, that even though I'm seeing some voltage and some noise, this isn't actually knock. This is relative engine noise, okay, and which is naturally going to occur. There's no way around it. You start getting into larger injectors, cams, throwing 8,800 RPMs at it. Just mechanically speaking, there will be more noise. It's going to happen. So what you're going to do is you're going to build this graph as basically like your threshold. These right here, and this is something really nice that the V2 has, and it's way more advanced than the Infinity and other systems, but the center frequency, this number is actually relative to the diameter of your piston. And if you guys do any research, this number, the actual frequency at which knock occurs, if you guys do some research, you'll notice that in between about 5 kilohertz and about 18 to 20 kilohertz, given how wide your piston is, will actually change this value more so than any other factor. So you're going to use this number. How do you come up with this number? Well, given whatever setup you have, how wide your piston is and all these kinds of things will change this number more than anything else. So this is kind of a lookup value that you can look up and set that and kind of forget about it. Obviously, if you've got a set of headphones, you can get much more accurate, but the gain is again how sensitive it is around the specific frequency. So a higher gain, you'll see a lot more erratic action when in your logs with all of your volts, especially in the raw values. And then the integrator is, in USEC, it's kind of like a scalar on top of the center frequency. So the best way for me to tell you guys how to do this is to, be on the dyno, look at your relative power numbers versus how much timing you're throwing at it. If you can, if you have a set of headphones that can, help to audibly discover knock and not just relative engine noise, that's fantastic. It really helps to set all of this stuff up. And in here, what you're going to get is how much fuel you're going to add per volt, the max amount of fuel that it would add if voltage did occur, the decreased fuel to actually reach a certain knock point. Because what this is going to do, not only can you use this as a threshold, but you can also use it as a target. So you can actually target this knock voltage, because this is your threshold. Everything above it is actual knock. Everything below it is not. And again, this is just a pre-set up value. This does not mean this is right for your setup. So you can actually do advance it to this point, and then when it goes over, pull it back. So it rides this line all the way out. And that's pretty much all I'm going to touch on with knock 2, because it's again, it gets so deep so fast. I really don't want to go any more in depth. You can do the research on yourself, figure it all out, and it'll start making a lot more sense. Okay, that's pretty much it, guys. Thanks for watching.